Hello and welcome to this lab. In this lab, we are going to work with the imagery data in ArcGIS Drone2Map software and create a couple of different products based on imagery data. So you can download the ranchodelmar.zip file, and after you downloaded it, you can extract it, and you can delete the zip file after it's extracted. Then you're going to see these folders as well as the Drone2Map project file. So I want you to open this project file. Just give it a couple of minutes to be loaded. After the project is open, it might actually ask you to log in with your account. So log in with your account, and then you might also see this error message, which basically means that if you move the folder, it might ask you to update the image path. So I can go ahead and change that path. I put it on my desktop, so I'm just gonna point to my desktop folder, which I have saved my images in it, and I have to also change it to the images folder. So let's do that, and these are the images. So it will be something like that under the folder name and the images, and hit apply, and it should fix the error message. And as you can see, the broken path were successfully fixed. And now that I have the images loaded, I can just talk about the Drone2Map software first. Of course, if you start from scratch, you can select a template. Right now we have two maps. We have the 2D map and 3D map. And then under the 2D products, we have image collection through ortho, digital surface model, the train model. And on the 3D products, we have other options. If you're using the basic version of the Drone2Map, the 3D products are not available for us, but still we can create a ortho photo. So what we can do, we can, it's already added here, the imagery data. We can see the flight path and the location of the camera at the point that we have, and then we can here go under the processing. If you want, you can change the setting for the dense matching. You want to set that to medium. And then for the just images, if you want, you can fix them if you have used RTK, PPK, which we don't have it here. And then you want to just skip that. We can select the ortho rectification method, or select a true ortho as well. Right now we're just gonna stick with the default. You can create a DSM, a digital surface model, and then also a digital train model as well, and then hit apply. And I'm gonna also select the true ortho as well, hit apply, and then I can start processing. So what is going to happen is, based on the imagery data, based on the metadata and all of the information about the images, the Drone2Map software identifies the camera, identifies the sensor, and other things related to that. And GPS coordinates would be used to correct and calibrate the information, and then just wait for it to be finished. So this process is going to take a while, so you just leave it open. Do not change or close that, anything within the software. You can work with other things until this is finished. All right, now the processing is finished. We can take a look at the information. So under the 2D products, of course, we see the ortho photo is added, so we can kind of look at the ortho photo. You want to see that. Let's uncheck the visibility for project file. And what happens here is that because you have the satellite imagery as the base map, you might get confused. Okay, what's the actual ortho photo? So if I uncheck that base map, we can find it. Word imagery, you can see this is the ortho photo of the area. Pretty high resolution. It's a good orthophoto that we have created. Of course, just the visual itself helps to validate what we have underground, but also we wanted to look at the other factors here. If you want to look at the options that the orthophoto was created, we didn't use any ortho rectification method or any type of correction. Usually for something like that, very small, it probably is captured only in one take, and then maybe in less than an hour. You don't need to make corrections for a lot of things, but especially lighting. But if you have other factors, if you have larger areas, other factors should be also considered. So that's the imagery orthophoto file. You can also take a look at the digital surface model that will be under the imagery product. So let's uncheck the orthophoto. You can see the DSM would take into account the elevation of the buildings, and if you look at the DTM, however, you won't see that type of thing. It will be different in terms of the elevation model, right? So digital surface elevation model. And then now you can run other types of analysis based on this information. You can look at the profile. Let's say I want to create a spectral profile. I can specify where I want that to be created. Right now I don't have any type of data. For example, I need to create a path for that. So if I do that, that would give me the elevation profile for that path. So imagine if you have a road network, you can create elevation profile for the area that you have path for. And you can specify what type of source you want to use for the elevation profile, right? Right now, we use in past part, we use DSM. Now, if you want to use the DTM, you can specify that. You can go under the properties. You already have that properties. You can see the minimum elevation, maximum average elevation, and actual distance. So this basically gives you the slope as well. You can do all other things here as well. Let's build elevation profile based on the DTM. Kind of seeing the difference between these two helps you to see actual how the buildings, these are the buildings on the DSM, right? So the surface model compared to the digital terrain model, which doesn't have that doesn't take into account the profiles. You can actually compare the profiles together as well. All right, so that's about the DTM and DSM and how to create a profile for that, and kind of looking at the profile, make some comparison. If you want to, you can even export as a graphic. Under the home, there are other types of options you can do. We already have done the pre-processing. You can take processing. You can take a look at the information here under the processing report. How many type points we have, or the Drone2Map has created almost 1.4 million records, and the timing it took my machine 17 minutes. Of course, might be it's definitely going to be different. We can look at the camera parameters. What's the name of camera? DJI Zenmus P1. It's a very good camera, of course. The focal length, other factors for that, and how many type points are per image. Looking at the projection error and overall RMSE, which is a good number. Looking at the exterior orientation, looking at the adjusted image locations, the overlap of the images. And as you can see, the green means this is a good overlap. And of course, we're going to have lower overlap on the outer bounds. And 6 plus means that 6 images are shown overlap, and the triangulation and how many points are used for different images. Then the dense matching, the project, the settings. Of course, that's my machine. Description will be different for you. And the coordinate system and the 2D product summary, that's processing time and other things for that. And that's about the project report. If you want to share it, of course, you can export this map or create an elevation layer, imagery layer, whatever you want to create, even the tile layer. You can also make some edits for the information you already have. You can raster, edit the pixels on the raster, the flight data we already have. Look at it, and excuse me, we can export the GPS or image altitudes as well. So that's about it, and I hope you enjoyed this video. And in the next video, we're going to work on a little bit more advanced things in Drone2Map. Thank you. I'll see you in the next video.